My name's Tim. Thank you for coming to my presentation. In this talk, I'm going to talk about building a data studio in your notebook, or more accurately, in JupyterLab. I tend to throw a ton of links in my presentation, so this is a QR code to like a PDF form, but it's clickable, so if you miss a link or something like that, you can find them all there. I'm a quantitative developer at Cubis Systematic Strategies. So Cubis is a part of a larger hedge fund. I build tools for research and trading, so long-term investing all the way up to like high-frequency trading. My GitHub is Tim K. Paine. And Point72, which is the parent company, also has a GitHub, so you can find us stuff that I do as well as stuff that we do as a company. And I'll just shout out that we do have, I looked up to make sure we have a Paris office in Madeline, and we have a couple of openings there. So if anything I'm talking about or the tools I'm talking about are familiar to you or interesting, feel free to apply. I'm going to talk about a little background and motivation. Basically, what does this mean? Why did we build this tool? What can you use it for? And sort of where to go from the end. For background, really, there's three things I wanted to talk about. One was just, I like giving Jupyter talks. So this project in particular uses a bunch of different parts of Jupyter on the server side, server extensions, different ways of interacting with sort of files on your machine, as well as front-end extensions for JupyterLab. Also, obviously, I'm going to talk about jupyter-fs, which is a library, kind of how to install it, how to configure it, how to use it, and just sort of how to reduce friction generally in your data science workflows or in your day-to-day life. So I think Jupyter is pretty established as the tool for researchers and data scientists basically everywhere. I'm a fantastic artist, as you can see. So this is my little picture of a data scientist doing their work. And I say a typical setup. In a lot of the setups I've seen and that we have at my company, the picture is maybe a little bit more accurate to look like this. You've got your little researcher, you've got Jupyter, that's their tool of choice for their day-to-day life. Maybe there's a compute cluster they can interact with. Maybe there's some data storage. I just wrote Postgres and S3, but wherever it happens to live. And a lot of that first experimentation, data exploration, exploratory data analysis stuff, workflow is probably a little bit more complicated. You are on Jupyter shipping off jobs to your cluster. That cluster is pulling data from Postgres, from S3. A lot of companies like business intelligence tools like Tableau or Looker. You might even have your own kind of, I wrote superset down, but you might have your own little custom place where you go and look at things. When you're exploring a data set, when you're trying to visualize results, if you are not the most comfortable maybe bringing things back into the notebook and visualizing them there, or even just doing that introduces a little bit more time, a little bit more friction. You're building libraries of like matplotlib code to visualize things. You can introduce friction and just make life a little bit more difficult. I think generally people like to have an all-in-one place where they can do everything. And since for data scientists that tends to be Jupyter, it makes sense to make Jupyter that all-in-one place. So jupyter-fs comes in basically right here. Get to leverage any extensions that you have installed if you have custom visualization tools, if you are just comfortable being in the notebook, but you want to bring all of that data into your notebook, maybe not directly, but at least to be able to explore it, to browse it. That's sort of what this tool is made for. Cool. So we have a pretty cool logo. It's actually owned by JP Morgan, which is a bank. I used to work at JP Morgan, and that's where we first built it out. But on the JP Morgan Chase GitHub, you can find the project. So what is it? How do I use it? What is it good for? So it's basically three parts, starting with the kind of Jupyter perspective. It's a contents manager, which I'll mention what that means in a second. It's a server extension, and it's a front-end extension for JupyterLab. So starting with contents manager. So contents manager is like the class name within the Jupyter kind of server ecosystem for the thing that serves up files and folders and stuff like that. So the docs look like this. There's a link in the slides. But it's kind of all of the things that you need to be able to do with a backend. It's pretty straightforward, the kind of obvious things you would expect. Getting a path, saving a path, deleting a file, renaming files, stuff like that. So, and then there's basically only three data structures that you care about: a notebook, a file, which could be text or binary, and then a directory, which is going to contain other files. So the default contents manager, and for the Jupyter people, I'm kind of lying a little bit, but the default contents manager is a file contents manager, which basically just reads and writes from your local file system. You can overwrite it, like with everything in Jupyter, you can override it via configuration. And so when you install jupyter-fs, this is basically what it does. It says, hey, use the jupyter-fs custom contents manager, and there's multiple ways of configuring it, and it's all in the README, so you don't have to pay any attention to this stuff. And we provide a couple of different contents managers, a synchronous and an asynchronous one. But what we actually do is we provide an interface to these two other libraries, which many people might be familiar with. They're integrated into things like Arrow and polars and stuff like that, but they're fsspec and PyFileSystem. So these are both file system abstraction libraries. The cool part about them is they provide this file system-like interface for all kinds of different backends. So starting with PyFileSystem 2, here's that project. Also, you can find it on GitHub. They've got local operating system, basically your local file system, FTP, SFTP. There are extensions for it. So here's an SSHFS, S3, Samba, things like that, right? So if you have a backend data storage, you can generally find either a PyFileSystem 2 interface to it, or if not, you can find an fsspec interface to it. So same deal, just probably a difference of 5 to 10 years between the two of them. fsspec, I think, is maybe slightly more modern. Just it's a little bit newer, and it's integrated into a bunch of maybe more popular data science libraries. But same deal, you've got local file system, you've got FTP, SFTP, SSHFS, S3FS. Basically, if you've got data living somewhere, you can generally interface, there's Samba, you can generally interface with it via one of these two libraries. Okay, so at a kind of bird's eye view, you're interacting from Jupyter, you've got your Jupyter server. All that jupyter-fs is doing on the back end is mapping that contents API into fsspec or PyFileSystem APIs. Great, who cares? Wow, great talk, Tim. Cool part is that basically means that you can run your Jupyter kind of file browsing mechanisms off of whatever backends you have. So if you have data files in S3 or notebooks in S3 or whatever you have, you can actually use that as your file system backend. Here's how I might configure something like that. I did a very boring one because Wi-Fi is usually bad when I'm going to give these talks. So I just did a local file system example of just pointing at a local file on my machine or a local folder on my machine and telling the jupyter-fs extension to use that. And in the front end, I'll see this new little file browser, which is that folder on my computer. Next part is the server extension. So Jupyter is awesome and extremely modular, as I'm sure everybody knows. But you can basically plug in your own backend components. You can override different things. So this is the mechanism by which we kind of shove our contents manager in and potentially provide different APIs or override existing APIs. So again, tons of documentation on it. This is part of the Jupyter server project. We're just leveraging all of this stuff that's already there. And again, when you install jupyter-fs, it's going to do a little bit of configuring to override some stuff. And then the last piece of the puzzle is the front end. So we use a Jupyter Lab front end extension, which again, I'm sure everyone has seen. And again, there's extensive documentation on which anyone can follow. And we wanted to do a separate tab for a variety of reasons. One was that the default, I know there's a bunch of issues on Jupyter Lab and stuff like that, people discussing it. There are a bunch of projects about new or different ways of viewing the file browser, but it provides this kind of paining view. So when you double click on a folder, it updates so that you're inside that folder. On Mac, this is the common paining view. And we just wanted something that was, you can expand a folder and see everything all in one page. It was difficult to kind of make the existing Jupyter one do that stuff. The other thing is one of the core reasons we did this project in the first place was we were interacting with a file system that would have thousands and thousands of files in a folder. And just rendering all of those DOM elements ended up slowing down Jupyter as a whole. Nothing to do with Jupyter, no fault of Jupyter, but just sort of the browser and having all of these individual elements. So we wanted something that maybe was virtualized, where we could have thousands of folders, even if it's not the best practice, and have it still work nicely. And we just wanted to have multiple of these things. So if we're working across multiple backend file systems, we wanted to have multiple file browsers, which I think wasn't possible at the time, but I think you actually can do. So we wrote, as one does, another library to do this type of thing. It's called Tree Finder. It's basically just a web component to do a file browser. So a lot of the same interactions that you would have on your local machine. It's built on, again, yet another library called regular table, which is just a virtualized grid for that scalability and performance that we were looking for. It looks like this. This is very small, I'm sure, but you can see there's a lot of folders and files. I think this is actually the jupyter-fs folder. It should look just like a file browser, just like you know and love, just in a separate tab over here. Okay, let's put it all together now. So that's what it is. It's just leveraging existing Jupyter infrastructure to provide this different backend across whatever data provider you might have. So at its most basic usage, you could just think of it as a drop-in UI replacement for the file browser. If you configure it to point at your local file system, it's just going to be the same thing as what's already there. That's a little boring, but it has all the functionality that you would look for: creating folders, uploading files, refreshing. Right-click interactions should be almost one-to-one with the regular Jupyter file browser. I mean, it's a little small, but it's all the boring stuff that open with, copy, cut, all that stuff. All of these other interactions that you might have, so if you have extensions for doing things, I know in particular for things like CSV or Parquet files, you might have like a Jupyter extension that you've been using. All of these things should also work, which is where things start to get a little bit cool. All of your existing extensions should work very nicely with whatever data backend you have, because it's just leveraging all of the existing Jupyter machinery. Just laundry list of all the things that should work. If they don't, please let me know. There is one big downside, which I do have to shout out, because I think it might be a little unfamiliar. We don't solve the problem of that the notebook that you're running and the kernel that you're running is going to be running locally. So if I'm connected to an S3 backend, that there's some servers in AWS or whatever that are running, obviously my notebook is still going to run locally. So this is maybe a little bit unexpected, but it allowed us an opportunity to produce something which I think is maybe the star feature of the library, which is snippets. So we have this ability as you're browsing through these different data backends. When you right-click on things in that context menu, you'll get a bunch of helpful suggestions for maybe specific to the file you're looking at, or generic ones. So if I right-click on a CSV file, for example, I'll get this collection of snippets to bind these two things together. I've got my browser where I can look through all my data, but then I can pop over to my notebook and I can do, write data frame as CSV or read CSV as pandas data frame, and that will actually paste a little snippet of code to connect to that remote backend and pull that data in, give me the code to basically pull that stuff in locally. So I'll show an example of this in just a second. They're registered. You can write your own snippets. We provide a bunch of them for CSV files, for, you can read as plain text, read as bytes, all these types of common interactions. You can create your own, and they're templated. So if you have like a permissioned, data backend that you've connected to from your front end, you can grab the little snippet of code that will connect to that permissioned data backend and pull it all in your notebook. All right, so this is what one of those snippets look like. It's a little small, but this is that read data as CSV. So I click snippet, read CSV as pandas data frame. It'll give me all of this code to grab that file system representation, connect to that same backend that I've connected to in my Jupyter front end, read that CSV and pull it into a data frame. And it's going to leverage one of those two data backends, so either the file system, PyFileSystem2 backend or the FSspec backend. So this is pretty cool as you're kind of browsing things within the Jupyter environment. Front end, you can then pull that same data inside of your kernel. You can also, just as a convenience, if you want to access or interact with the PyFileSystem2 or FSspec thing directly, so I think Polars lets you do things where you can customize the, you can connect to an FSspec background or backend. You can always just do that same thing. Okay. So I got a brief demo, or actually just a couple more features. I've got a brief demo, which I'm not going to do live, I don't think, because the Wi-Fi usually hurts me a little bit connecting to my S3 buckets. But the key takeaways here are just that it's the Jupyter environment you know and love. Everything you've installed there will continue to work there. You just get access to, in that nice, familiar environment, any data backend that you can imagine. We have a bunch of extra features here. They're listed in the README, but all this configuration, you can configure client-side or server-side. There's mechanisms for authentication. So if you've got like a Windows share drive that your users need to connect to, you can make it so that it's configured for everybody, but when they connect to it, it prompts them for their password or something like that. And obviously, you know, building on the back of Jupyter and these two file system libraries means that, you know, you get a ton of, you know, backends. You can write your own backends if you want. You can write backends, file system-like backends for things that aren't file systems, which is kind of cool. You could think about one that I'm working on is for SQL databases. So you can think about a file system-like view for what are all my tables, and then you go into a table folder and you get, you know, what are all my columns. So it's just a very nice interface. So quick demo. I'm going to do a couple of things here. I've connected to 2 local folders and an S3 folder. I think it's on Backblaze or something like that. So it's a little slow, which is why I don't do the demo live. I have it open next to me, but I was testing on the Wi-Fi, and it's, you'll see, there's a little bit of lag. I'm going to use a handful of Jupyter extensions just to like interact with it, browse it, looking at CSV and Parquet files. So I want to pull it into maybe the native CSV viewer or a Parquet viewer that I wrote, and then I want to kind of move over into the notebook or move between the notebook and the Jupyter Lab browser and, you know, kind of do different things. So this is the native browser. I've got the CSV and Parquet file. I can pop over to the first kind of backend instance that I have, which is just a local file system instance. All those interactions are going to work. I can read the CSV as a data frame. There's that snippet mechanism we talked about. Now, you know, spoiler alert, I have the data frame in my notebook. This is an S3 backend, so it's a little slow, but I can browse through S3, same familiar file system interface, nice and scalable. I can fully expand things. Here, I'm just going to copy that same thing, read it as a pandas data frame. Great. You can see it's a little different there. We've got the S3 FS spec URL, but again, maybe not the most exciting demo. I can pull it in. I can use extensions and stuff. I can, you know, plot it if I want. All of the native Jupyter Lab integration should also work. So I'm going to open it with the CSV viewer. Works fine, great. Local CSV file works great. Here, custom Parquet viewer that I wrote. Again, local file system, awesome. Same interaction off of an S3 bucket. CSV viewer works great, a little slow, just because of S3. Same deal, all of those extensions, custom extension for Parquet, working fine. So maybe not the most flashy and exciting of end demos, but that was sort of the point at the beginning. Reducing any friction, reducing moving between tools, having everything in one place, leveraging extensions that you've written, making it easy for you to go from here I'm browsing S3, now I actually want to pull that one file. It's 2 clicks to be able to do it from inside your notebook. There's a couple of things that are still kind of on the table. So a lot of people have said they want it in a single file browser. I think this will be a big feature. It's almost done. But just being able to connect to, let's say, 4 different S3 buckets all within the same file browser and using those native Jupyter interactions. So just dragging something from one bucket to another bucket. Right-clicking on a couple of different things and, you know, pulling it all into the same notebook. There's a bunch of other backends. A lot of the ones that I mentioned before are file system-like. So Samba, S3, SSHFS, but there are other more interesting ones, things like SQL databases that I think really hammer home that like it doesn't have to be a file system in the backend. And there's some emerging projects, so sometimes we have some conflicts in terms of, you know, leveraging all of this Jupyter extension machinery. We conflict with things like jupyter-text. There's a project coming out which is jupyter-fs spec, which is a similar motivation, and actually we've been talking about merging the two. And also, there's always conversations, and there's a JupyterCon coming up where there's a lot of talk about, you know, changing file browsers, you know, adjusting the user experience. So I try and float into some of those conversations as well. I think that is all. I'll just leave the demo open in case it was a little quick, but I'm happy to answer any questions.
Okay. Thank you, Tim. That was an amazing talk with, again, a practical demo. So now time for questions.
Thanks, Nick. That was amazing. Have you played at all with tools for fusing remote file systems into the current local file system, the one used by the kernel?
So like mounting things?
Yeah, like mounting
So
with Fuse or things like
one
that.
of the original motivations when we were doing this project was we had like an object store where people tend to store their code actually. And then there was local file systems where people tended to store their data. It's kind of the inverse of what it usually is, but that was just the setup at JP Morgan at the time. And we were in a type of environment where like there were Windows users, for example, so that's always tricky mounting things. But there was no elevated permissions, and things like Fuse can often require some pre-work to be done or some local admin. So we wanted it to all be kind of user space and light. So we looked at it originally. I mean, we wanted to not have to write this project by just doing that originally, but it didn't end up working out. I think there are still valid reasons to do that, like performance-wise. I think it's probably faster, especially if like, S3, for example, if you're connecting the way we do it, it can lead to some like heavy list operations and stuff like that. But if you use, what is Amazon's thing? Lustre, FSX, I think is their kind of backend. I think it can be a little bit faster. But we had, looked at it, but the constraints were basically that we couldn't, because the users basically couldn't do anything on their local machines. But I would definitely still recommend, if you can get away with it, rclone will let you mount a S3 bucket. Doing everything natively is probably a little faster.
Oh, I really meant mounting FSPEC.
Oh,
FSPEC
no, I haven't.
Things in your local file system.
No,
there's an experimental feature on FSPEC.
Oh, no, I haven't looked at that yet.
Exactly.
But I think it's probably the same motivation, is that like if you do have that level of control over your local setup, this only works in Jupyter still. So if you want it to work in VS Code, having all those things mounted is probably a little bit better. But one of the nice things is that, if FSPEC supports it, we can generally support it. And, we're in conversation with the maintainers.
Great.
Thank you for the presentation. I have two questions. The first one is, can it be adapted to work in Jupyter-Lite in WebAssembly? And the second question is, when you authenticate in the file browser, for instance, you have a S3 bucket with a specific permission, do you have to re-authenticate when you execute the snippet on the kernel side? Do you have twice the login, or can you propagate?
Two good questions. The first one, I will apologize. I forget who I yelled at somebody when they first were doing, the Jupyter-Lite has its own file system extension, but it's the browser local file system. I haven't had enough time to look at it. I think it would make a lot of sense to be in kind of a Jupyter-Lite environment, that there are going to be some tricky parts. We don't do a ton of our own like web requests. So generally speaking, like if you would otherwise be able to connect to S3 from a browser, you should still be able to connect to S3 from a browser. So I think it would make it very valuable, especially because it's so easy if you're on a Mac or a Windows machine to just have a Samba shared drive of your machine. It means you basically would never really need a local machine. You could always connect to your server over Samba or something like that, and when your experience would be perfect. It would all just work nicely. What was the second question? The authentication. Yeah, so in the UI, well, I should probably just go to the website, but there are two mechanisms for authentication. It'll either prompt, or you can set it up in the environment. Generally, when we would set this up in enterprise for a lot of users, we would just set it to prompt. It would be like, password goes here, prompt the user. When you configure a backend, you have this option. I don't know if I put an example in here, but when you load up one of these backends, one of the options, name URL, will be auth, and then the options are like ask or environment. So if it's something where it's like, it's your local file system, you don't want to have to keep typing things in, you can just set it up in environment variables, and we'll pick those up in the URL. So this is a template. Or the backends themselves have a bunch of environment variables. So for FSPEC, I sometimes use those. For the S3FS, basically, there's a couple of things to set, and you can just set them always, and that'll be picked up. But if you set it to prompt in the front end, it will re-prompt you. Like it'll be, missing in the backend part, just because we didn't want to do like an input or anything like that. Yeah. But if you set it up as environment variables or anything like that, then it'll work across. Yep.
Okay. Any more questions?
Thanks. Great talk. I was wondering if you tried using Jupyter collaboration, for example, with an S3-backed file system. You mentioned...
Oh, it's probably going to be rough. I think it's like that's the logical conclusion for some of these things. I know my S3 backend is quite slow to begin with. So I think if there's conflicts, if there's a conflict-prone setup, it's probably the S3 backend that I use and this mechanism. I haven't tested it directly with the collaboration stuff, but I think if you have a reasonably fast backend, it's another great, a great use case or a great blending of tools. It's like you have a shared drive, you're working together, you want to store a bunch of things against that shared drive. You have like a shared space that people can work. You can connect to it from the front end. I didn't show it, but like you can obviously like all your notebooks and all your code can live and be interacted with across those backends. I don't think I have a notebook over here, but I don't know if I had like a markdown file. I think this is empty, but you can work on these things and if assuming the collaboration is a little bit okay with some network latency, it should work fine. It is just the vanilla contents manager backend. So long as those work together, it shouldn't be a problem, but I haven't tested it.
Thanks.
Thank you. Any other questions? I have one in that case. What do you say about implementing this in a Google Colab kind of environment?
Yeah, so I mean, the file browser stuff, sort of the front-end components are really the only thing that's specific to, I mean, the back-end stuff is specific to Jupyter as well, but if other tools use that same type of mechanism, it should work fine. I generally don't worry too much about Google Colab because it's a proprietary product, but I think this is like, rather than, I think the Jupyter way of doing it is probably the right way of doing things because they provide these extension points for you to say, I want my own contents manager. I want to plug my thing in here. And so long as you abide by those APIs, it'll all work nicely. I haven't really seen that in too many other tools. Like even things like VS Code have full extensions for you to just like, okay, now I want to just run VS Code off of a server. There's, like a SSHFS extension and stuff like that. But I think the way that Jupyter does it makes it very extensible, and I haven't seen that as much in other tools, but not too much of this would translate to them.
Great, and just one question. It's equally, I would say, performant in all kind of OS like Windows.
Yeah, it should be one of our main use cases was like being able to work on a Windows machine, but connecting to a bunch of different remote sources. So again, if something doesn't work, please let me know. It's still a work in progress, so there are bugs, and there's these conversations with the FS spec folks, but it should be fully cross-platform.
Okay, thank you very much.
Thank you.
So if we don't have any other questions, that would let us applause team once again.